Now we are continuing with CVP analysis MCQs. A company has put together the following budget based on production and sales of 5,000 units, sales 45,000, cost of sales 29,000, administration cost 12,000, and net profit is 4,000. The following information is also available. Variable production cost per unit is budgeted to be $5. Administration cost include $2 per unit selling cost and the remainder representing fixed administration overheads. What is the margin of safety in percentage terms? So margin of safety percentage is equal to budgeted sales minus break-even point divided by budgeted sales into 100. So we are provided with the budgeted sales of 5,000 units. Now we need to calculate break-even point units. To calculate break-even point units, we need fixed overheads and contribution per unit. So first of all, we will exclude $5 is variable production cost. So total variable production cost $5 into 5,000 units, $25,000. And we have total fixed production cost is equal to 29,000 minus 25,000, 4,000. Apart from this, we have total variable administration cost, $2 multiplied by 5,000, it's $10,000. Total fixed administration cost is $12,000 minus $10,000. So we have 2,000. $6,000 is the total fixed cost divided by contribution per unit. We have total sales revenue of 45,000. So we need selling price per unit 45,000 by 5,000, $9. So the selling price per unit is 9. Variable production cost is 5 and variable administration cost is 2. So we have 9 minus 5 minus 2, contribution of $2. So 3,000 units is break-even point units. Now we will follow this formula of margin of safety percentage is equal to 5,000 minus 3,000 divided by 5,000 into 100. So margin of safety percentage is 40%. GG manufactures a product that has a selling price of $15 and a variable cost per unit of $6. Annual fixed overheads 43,875 and annual sales demand is 6,000 units. New manufacturing method are being considered for the product. These would result in a rise of 20% in the fixed cost and the reduction in variable cost per unit to $5. New manufacturing methods would create a higher quality product and sales demand would increase to 7,000 units each year at a higher sales of $20 per unit. If the changes in the manufacturing method are implemented and if the selling price is raised to $20, break-even level would be. So first we need to calculate current break-even point units is equal to total fixed cost of 43,875 divided by current selling price is 15 minus variable cost is 6. So the contribution will be 9. 43,875 divided by 9, 4,875 units. Now we will calculate revised break-even point units is equal to fixed cost will rise by 20%. So 43,875 multiplied by 1.2, 52,650 divided by. Now the contribution has increased to selling price has increased to $20 minus variable cost per unit has reduced to $5. So it is 15. 3,510 units is the revised break-even point units. So break-even point units are following: 4,875 minus 3,510, 1,365 lower. So this is the right answer. Next one is, if both the selling price per unit and variable cost per unit of a company rise by 10%, the break-even point will be. Rather than making any kind of assumption, we are going to assume a data. And it will be better to assume data in such type of questions. You can assume by your own self, like you can say that our current selling price is $10. Suppose current variable cost per unit is $6. Current fixed cost is like 30,000 units, $30,000. And now we calculate current break-even point is equal to fixed cost of 30,000 divided by selling price 10 minus variable cost of 6. So 30,000 divided by 4, 7,500 units. Now we are talking about revised. Revised selling price is 110% of the $10, which means 11. Variable cost will also rise. So 6 is rise by 10%, 6.6. So we will calculate what? Revised break-even point. Fixed cost is same divided by selling price of 11 minus 6.6. 30,000 divided by 11 minus 6.6. 6,818 units. So break-even point units is what? It is falling from 7,500 to 6,818 units. The budgeted cost of only type of the product made in the factory of SD based on expected monthly level of production and sales of 1000 is as follows. Variable production cost is 5.6, fixed production cost is 5.8, variable selling cost is 3.4, fixed selling cost is 4.6, break even point units. So break even point is equal to selling price minus variable production cost minus 3.4 variable selling cost. To calculate what? This will give us contribution per unit. So we are also going to calculate fixed cost on the activity level of 1000. Fixed production is 5.8. We have the same production and sales, so rather than multiply by 1000, we can add fixed selling cost over here with 5.8 plus 4.6, and this whole is multiplied by 1000. So it will give us fixed cost divided by what? Contribution per unit. So first 5.8 plus 4.6 multiplied by 1000, $10,400. Let me check once again. 5.8 plus 4.6 into 1000 units. Yes, it is correct. Divided by what? Contribution per unit 24.9 minus 5.6 minus 3.4. So we have 15.9. So 10,400 divided by 15.9, 654 units is break-even point. AL makes a single product which it sells for $10 per unit. Fixed costs are $48,000 per month, and the product has a contribution to sales ratio of 40%. In a period where actual sales are $140,000, margin of safety in units was. So to calculate margin of safety in units, first we need break-even point units, where we have fixed cost of 48,000 divided by contribution per unit, which is 40% of the selling price. CS ratio is 40%, so the $4 is contribution per unit. 48,000 divided by $4, we have break-even point units of 12,000. Now we have actual sales revenue of 140,000. So we will calculate actual sales units is equal to $140,000 divided by 10, 14,000 units. Now we can calculate margin of safety units is equal to 14,000 minus 12,000. We have 2,000 units. So this is the answer. The following information relates to product P. Selling price 65, material cost 22, labor cost 14, variable production cost is 9, fixed production overhead cost is $10, and budgeted output of the product P is 12,000 units. Assume that no inventory of product P is held. What number of units must be made and sold to make a profit of $18,000 in the year? So here we have targeted profit of 18,000. Step number 1 is to calculate targeted contribution, where targeted profit plus fixed overheads, which is 10 per unit, and the normal activity level is 12,000. So 10 multiplied by 12,000, 120,000 plus 18,000. 138,000 is targeted contribution. Number two, sales units required to achieve targeted contribution is equal to 138,000 divided by contribution per unit, 65 minus 22 minus 14 minus 9. So 138,000 divided by 65 minus 22 minus 14 minus 9. So 6,900 units are the required sales units to achieve targeted contribution. B makes and sells a single product which has a selling price of 26. Prime costs are $10 and overheads all fixed are absorbed at 50% of the prime cost. Fixed overheads are $50,000. The break-even point units is break-even point is equal to fixed overheads 50,000 divided by contribution per unit, where we have selling price of 26 minus variable cost of 10. So we have 3125 units. A company has established the following information and for the cost and revenues at an activity level of 500 units. Direct material 2500, direct labor 5000, production overheads 1000. Remember, here we have production overheads. There is no word of variable production overheads, neither the use of fixed production overheads. So it means this one is semi-variable cost, and probably it will divide into two proportions. One is called variable cost per unit and the second one is called fixed cost per period. Remember, variable cost is always on the per unit basis and fixed cost is always on per period basis. Selling cost is 1250. Again, there is no specified word of variable selling cost or fixed selling cost. So we can assume that as it is also mixed selling cost, which includes variable and fixed both. Total revenue is 17,500. 20% of the selling cost and 50% of the production overheads are fixed. So 50% of 1,000, $500 is fixed, and 20% of this selling cost, 1250 into 20%, 250 is fixed. So total is 750 fixed. Now the question is, what would be the profit at an activity level of 1000? To calculate profit at an activity level of 1000, we need current contribution per unit, which is determined at an activity level of 500, or we can alternatively say that direct material is 500 multiplied with the 2500 at a level of 500 units multiplied with the 2, it will be 5,000. Direct labor 5,000 at 500 units, at 1,000 it will be double because it is a variable cost. Fixed production overheads are 500, but variable production overheads are also 500. So variable production overheads are also 50%, which is 500. So we can say variable production overheads 500 multiplied by 2, because $500 at an activity level of 500, at 1,000 it will be double. Similarly, we have fixed production overheads. It will remain fixed at the level of $500. Then we have selling cost, variable selling cost, which is 80% of 1250. Variable selling overheads or variable selling cost 1,000. At 500 units multiplied with the 2,000. Fixed selling cost, which is 250. So first we will add up all these costs. 5,000 plus 10,000 plus 1,000, 500, 2,000 and 250. 18,750 is total cost. Now we have sales revenue of 17,500 at a level of 500 units. At 1,000 it will be double. So minus 35,000. $16,250 will be the profit. A company has calculated its margin of safety of 20% on budgeted sales, and budgeted sales are 5,000 units per month. What would be the budgeted fixed cost if the budgeted contribution was $25 per unit? Okay. So we have margin of safety of 20%, which means break-even point units are 80% of 5,000 units. So it is 4,000 units. Now he is saying that budgeted contribution of $5, what would be the fixed cost? We have 4,000 on left hand side. Fixed overheads are X on numerator and 25 is the contribution per unit. You can calculate fixed production overheads by multiplying 4,000 units with $25, which is 100,000. So this is the right answer. Which of the following describes the margin of safety? Margin of safety is above break-even point. Actual contribution margin achieved compared with the required to break even. Actual sales compared with sales required to break even. Actual sales versus budgeted net profit margin. Actual versus budgeted sales. Actual sales compared with the sales required to break even. EPLC operates a marginal costing system. For the forthcoming year, variable costs are budgeted to 60% of sales value and fixed costs are budgeted to be 30% of sales value. If EPLC increase the selling price by 10%, fixed cost, variable cost per unit and sales value remains unchanged. The effect on PLC's contribution would be. So once again, we are going to assume a data in this question rather than making any judgment. We say that our current selling price is $10. We have current variable cost of 60% of this $10, and suppose we have fixed cost of 30% of $10, which is 3 multiplied by, suppose 10,000 units, $30,000. If EPLC increases its selling price by 10%, so revised selling price is equal to $10 into 1.10, 11. Rest of the cost will remain the same. Variable cost is 6 and fixed cost will remain 30,000. Requirement is what would be the effect on contribution. So current contribution is 10 minus 6, 4. Revised contribution is 11 minus 6, 5. So now we can calculate increase. 5 minus 4 divided by 4 into 100% or into 100. So there is increase in contribution by 25%. So contribution is rising by 25%.